for today's video, we will be discussing about how to get the inverse Laplace transform of a unit function. From the previous video, we had already discussed what is a unit function, how to get the unit function, and how to get the Laplace transform of a unit function. So for today's video, we will be discussing about how to get the inverse Laplace of a unit step function. So we're just gonna learn about that today. So the inverse Laplace of a unit step function has a general formula of Laplace inverse of e raised to negative as f of s is equals to f of t minus a u of t minus a. So we just have to remember this formula and we will be all good to go. So let's try using that formula in one problem so we can understand more about it. So here, our problem is Laplace inverse of e raised to negative s over s. First, we need to look at the e raised to negative s over s. So, that e raised to negative s or the numerator here will serve as e raised to negative as in the general formula. So, we can use that e raised to negative s in finding a. So, how to find a? We just have to look at the numerical coefficient of the exponent of e. So, the exponent of e here is negative s. So, let me just write it down here. The exponent of e here is negative s. So as you can see, negative s has a numerical coefficient of negative 1. So its numerical coefficient is equals to negative 1. But our a is supposed to be the negation of that numerator because in our general formula, a is negative. So we also have to negate the numerical coefficient of the exponent of e. So we just have to negate negative 1. So negating negative 1, we will have negative 1 times negative 1, we will have 1. So that is our a. Next, we need to find the f of s. How could we find the f of s? So, if e raised to negative s serves in e raised to negative as, now the only thing that left on us is 1 over s. Okay? So we just have to get the Laplace inverse of 1 over s. So which means 1 over s is our f of s. So we just have to get the Laplace inverse of 1 over s. The Laplace inverse of 1 over s is simply 1. So, now that we have the Laplace inverse of the f of s, you already have the f of t. But f of t is not the thing that we need. We need f of t minus a. So, how can we get that? So, we can get f of t minus a if we substitute the t in the function f of t as t minus a. So, as you can see here, 1 doesn't have any t. So, we don't have anything to subtract. So, our f of t will now be also equal to our f of t minus a. So, this is also equals to f of t minus a. Okay? Now, we just have to put all this in the equation. So, let me just copy the whole equation here. So we just have to get the Laplace inverse of e raised to negative s over s. Right? So as we said, our f of t minus a is 1. So we just write 1 here. Then we just need a u of t minus a. We just write u t minus, what is our a? 1. So it will become u of t minus 1. Now, simplifying, we can just remove the 1 beside the u. We will have Laplace inverse of e raised to negative s over s will now be equal to simply u of t minus 1. That's it. That's our final answer. Now, let's try another problem. Here, we have the Laplace inverse of e raised to negative 2s over s. So first, let's look at the e. The e here has a numerical or has an exponent of negative 2s. Which means, so we have negative 2s. Which means our n will now be equal, or our numerical coefficient is now equal to negative 2. I'm sorry for my handwriting. So, our numerical coefficient of negative 2 and the negation of negative 2, which is our a, will now be equal to simply 2. That's it. Now, let's get the Laplace inverse of f of s. So, since we get the e raised to negative 2s, the only thing that left for us is 1 over s. So, we just have to get the Laplace. Wait a minute. So, we just have to get the Laplace inverse of 1 over s. So, like earlier, the Laplace inverse of 1 over s is simply equals to 1, right? So, like earlier, 1 is our f of t, which also equals to f of t minus a. So now we only need to find the u of t minus a. So let's just put everything in one equation. So the Laplace inverse of e raised to negative 2s over s is equals to 1 of u of t minus our a, 2. Now, simplifying, we will get the Laplace inverse of e raised to negative 2s over s will now be equals to simply u of t minus 2. That's it. Now, our next problem is the Laplace inverse of 1 over s squared plus 1 multiplied to e raised to negative pi s. So, as you can see here, our e has an exponent of negative pi s. So, this is the exponent of e, and it has a numerical coefficient of negative pi. And as you always say, our a is the negation of our numerical coefficient. So, the negation of negative pi, so negative pi times negative, it will be simply pi. Now that we have a, we need to get the Laplace inverse of 1 over s squared plus 1, which is our f of s. So, we need to get the Laplace inverse of 1 over s 1 over s squared plus 1. So, getting the Laplace inverse of 1 over s squared plus 1, we will have sine t. So, if you haven't watched already how to get the Laplace inverse of 1 over s squared plus 1 over s, we have videos for that. You can go on and watch it so that you can understand what we are doing. Now, this f of t is, this sine t is our f of t. But what we need is f of t minus a. F of t minus a. How can we get our f of t minus a? We can just simply substitute t minus a on sine t. I'm sorry, I cannot write a. Okay, there we go. So we could just substitute t minus a on t on sine t. So substituting, we will have sine. Substituting minus a here, we will have minus. Our a is pi. That's why it becomes t minus pi. But this is not the answer yet because we can still simplify this. So, sine of t minus pi, using trigonometry, this is sine t times cosine pi minus cosine t sine pi. Now, sine pi is equals to 0. So we can just cancel this equation out. And cosine pi is equals to negative 1. With that, we can write sine t minus pi as negative sine t. Substituting it to our equation, we will have the Laplace inverse of our given 1 over s squared plus 1 multiplied to e raised to negative pi s will be simply equals to negative sine t u of t minus our a, which is pi. Now, this is our final answer. Easy, right? It may be confusing at times, but you can do this. Now, let's move on for our final example for this part. So, here we have the Laplace inverse of e raised to negative s all over s squared plus 2s plus 1. So, first, we need to find, or we need to look at the exponent of e raised to of e. So, here, the exponent of e is negative s. Now, we need to find a. What is a again? A is the negation of the numerical coefficient of e. So, the numerical coefficient of e here, or the numerical coefficient of the exponent of e is negative 1. Then, the negation of negative 1 is simply 1. So, our a now here is equals to 1. Now that we have a, we need to get the Laplace inverse of our f of s. Since we already secluded the e raised to negative s as the e raised to negative as of our general formula, we are now left with 1 over s squared plus 1. So that will serve as our f of s. All over 1 all over s squared plus 2s plus 1. As you can see, this s squared plus 2s plus 1 doesn't have a direct formula of how to get its inverse Laplace. So we need to manipulate it first. So manipulating, we will get Laplace inverse of 1 all over s plus 1 squared. If you are wondering why s plus 1 squared, it is because this s squared plus 2s plus 1 is a perfect square of s plus 1 squared. So if you expand s plus 1 squared, you will get s plus 2s plus 1. So this one is an example of a s translation axis of a Laplace. So given that, we treat this first as 1 over s squared. We ignore 1 first. Oh, I forgot the negative 1 here. So we need to imagine that this is 1 over s squared first. So given that, we need to find the n. So the n here, so 2 minus 1, so it's 1. So 1 plus 1. Given that it is s raised to 1 plus 1, our n now is 1. So it's 1 factorial over here. So given that it is 1 factorial over s raised to 1 plus 1 and our n is 1, our Laplace inverse of 1 over s squared is equals to t raised to our n, which is 1. So it is simply t. So this is the Laplace inverse of 1 over s squared. This is the Laplace inverse of 1 over s squared. But that is not what we are trying to find. We are trying to find the Laplace inverse of s plus 1 squared. So to get that, we just need to copy the t. And beside t, we will write e. And then, beside t, we will just negate the number that we added to s. So we will negate positive 1. The negation of positive 1 is negative 1. So that negation will be the exponent of e. And beside that, there's always a t. So negative 1 t. So simplifying, this is t e raised to negative t. So this is now the Laplace inverse of 1 all over s plus 1 squared is now t e raised to negative t. So e raised to negative t is our f of t, but f of t is not what we are looking for. We are looking for f of t minus a. So now let's try to find f of t minus a. So f of t minus a, so we will just substitute t minus a for t here in our f of t. So substituting t minus a, so our t here will become t minus our a, 1, e raised to negative t minus our a, 1. So that's it. That's our f of t minus a. We can now just substitute it through our equation. So the Laplace inverse of e raised to negative s all over s squared plus 2s plus 1 is equals to our f of t minus a, t minus 1 raised to e, I'm sorry, I'm just gonna write it, raised to e negative t minus 1. U, let's not forget our u, t minus our a, 1. Now, this is our final answer. This is our final answer. That's it. So, I hope you had learned something and understand what I am doing. And see you on the next part of this video. We will solve an IVP problem. Thank you.